angle, or excuse me, parallel to that, it's going to be right about the same point that that is. It's going to be distorted. And what about this one over here? Run a line parallel to that. If you can get it perfectly parallel, it's going to be there. And that should be a right angle, which it is. It's a right angle because it's echoing that right angle. So I found this was all work, scaffolding, so that I can get rid of it. I could just project these lines down here, but I want to keep this up where you can see it. Now I've got to take all these lines, drop them perfectly vertical. I should use the straight edge, but for time's sake, I won't. Get rid of this thing too. Drop them perfectly vertical, because if you take an edge like this and go like that, they all stay the same way. You know, they stay on that same vertical line. And then a vanishing point over there. Now, horizon line. Where should I put it? How about a little low so that I can look up at one of these objects? Or let's say we'll look up at both of them. How about if I put the horizon line down here? Front corner of that. We've got we don't know anything about the height of this, do we? Let's decide where we're going to put the front corner. How about right there? We don't know how high it is, so what have we got to do? We've got to find, let's do the elevation over here. Let's say that that box is that high. That means you just run those lines across there, and you'll find the height of that front corner. Did you see what I did? You'll find the height of that front corner when it's not in perspective, touching the picture plane, not foreshortened, not diminished. Now what have I got to do? I've got to go from here, where? I want a line that's going away to my left. Where is away to my left? Down here, right? That was the vanishing point for that line. It was down here, so I'm going to go like this. And where does it hit? It hits this back corner, which is right there. Now I want to go away to my right, and where was the vanishing point? We decided it was right there. We'll put it there. It's down this way, which makes a line that will hit, where are we trying to hit? That back corner there. Now what? It's a matter of connecting the dots, isn't it? We're going to do the same thing from that point down there. From that point down there. That's going to be a straight line like so. That's going to be a straight line like so. Now we need to find one other point, which we could find by connecting the dots. But we happen to know that back corner should be right there on that line, which means it should intersect, and it does. I was straight enough with my lines. Do you see what I did? Let's say this one is a little lower. And let's say that it's a cube. No, let's flatten it out a bit. It's in one-point perspective. Where was its vanishing point? We decided it was right there, and it's got to be on the horizon line right there. So we'll make it the same height as this thing. We've got to find one of our front lines. This point and this point would not be foreshortened. Let's put the height of it right there, and let's project. We'll say that it's shaped, if we could see it, right? That should be the same as that, but the height is different. It's like a wafer. We should be able to go across there, take that height line, and now what? That's the front plane. That's not in perspective, right? 1 point. That's not, we've taken this, look at, all we've done is taken this and gone like so. Watch. Right? So we can now see the edge of it, which is like so. Now, to vanishing points, happen to be 1 point. It should converge that this back corner should hit right there, which means I can do a vertical line and connect those dots. What about that back corner? Should be right there. It is. It was accurate. Seeing it a second time, did it make sense again? Or make more sense? Go ahead, David.
That doesn't make sense.
It's distorted. I have made the picture plane wider than it should be. Remember, you can do, this is let's do this thing in 1-point perspective. Let's say that's the horizon line, and we've got this object in 1-point perspective. Remember, we can put it over here too. We can just slide that thing around and keep it in 1-point perspective. The problem is that it will start to distort. Eventually, we'll need to turn this into what? 2-point by going like this, right? But the thing is that you don't have to, I mean, if you want to keep it true, you're going to have to do that. That's simply a distorted 1-point perspective to try to make this point and keep it in 1 point. What I did was I pulled it out of you. I knew that I was going to do that when I had my vanishing point for this object over here. It's like you've stretched that thing out. How would you solve that problem? In the plan stage. Remember, there were 2 steps. The plan step, where I did all that scaffolding, and then the projection step, where I've got the lines projected down. 2 steps. Where would I have solved the problem of the distortion? In the plan step, what would I have done? It would be very simple. I would have taken our character who was seeing this and moved them where? Oh. I could have moved them to the right. That would have done it. But that still wouldn't have solved. It would have created distortion for the 2-point. I could have done what with them? Moved that person away from the picture plane. And what happens? Let's go back to picture plane, plan, character looking at these things. What happens if I move them away? Where are the vanishing points going to be on that picture plane? Remember, parallel to that, parallel to that. Is it a right angle? Yes, that's where the vanishing points are going to be. But you know, you've only got, that's a 90-degree angle. You've only got 60 degrees maximum cone of vision, so you're only going to be able to see that much of it. Say that I've got something over here I want to see. I can do one of 2 things. I can distort, which is what I did, or do what? Move this character down to here, and what happens with the vanishing points? Keep the angle the same, right? Parallel to that, and look at those vanishing points move way out. Oh, that should be even further out, because that's got to be a right angle to echo this right angle as that was. Since it stays a right angle, the further you pull it away, the further the vanishing points creep apart, the less distortion, the more you can see without distorting. As soon as you can see 90 degrees or more, you've got serious distortion. Yes?
Wouldn't your picture plane change, though, if your view?
Oh, well, yeah, but the thing is, and in fact, that's what happens in life, but it isn't what happens when you do this, because you're trying to simplify. In other words, as I'm talking to you, look what my head's doing. You know, just that much movement, what has happened? Picture plane has gone boom, 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 boom. You know how many lines you're going to end up with? You'll end up with thousands of lines if you try, and that's kind of what Cubism was doing on a more intuitive level, because it wasn't concerned with picture planes. I mean, you could get around on the other side of the object. But one of the things that the Cubists were doing was showing you that things don't exist just from one point of view. Whether you can see them from one point of view is another thing, but they exist all around. And so they're starting to fragment vision. But what we're trying to do is keep it as simple as possible. I did keep it as simple as possible and ran into distortion. You could curve your picture plane. You could make it, and that's more like what's happening in your line of sight. You could make a picture plane shaped like that and see what happens. But if you're coming to the point of doing this, I'd say go back to freehand. You know, you can do all sorts of tricks with this, but it's like, why? When you're composing on a picture on a canvas, you've got that canvas, and you've got somebody here, and you've got somebody here, and you've got a foreground or whatever. You don't want to do plan projections for these people. But you might, if you want everybody's face to look like it's kind of distorted, you might build a box that's really distorted and make it so that things get really big as they come toward you, and then do the same thing with that person back there. That's not possible with a lens. I was telling Kelly the other day, Reed Miles, the photographer, for years did this trick, which this was before computers. He was a photographer, did illustrative photography for many years, and the stuff was a lot like Norman Rockwell's. He would have a whole bunch of people standing in line waiting for something, and all these people were really caricature. They looked like, how could you photograph people that were so caricature? Well, what he'd do is he'd have each model stand there, and he'd have somebody get up on them with a wide-angle lens and shoot a wide-angle photograph of them, right, with an expression. You know, they'd have that effect. And he'd have 20 people photographed that way. Then he'd have a retoucher cut out all those people, place them in the line, do another print of that, and then retouch the edges so it looks like one thing. And all these people have a wide-angle effect on them. You can't do that with a camera in the real world. You'd just get a wide-angle effect of all the people at once, but you wouldn't get a wide-angle effect on each person's face. You see? And that's what you can do. You can make little wide-angle boxes here. You can do anything you want to with your Illustrator. You don't have to hire expensive retouchers. Right? You don't have to have a person take a photograph of them. You can do all this freehand. The strength of this is when you have to be accurate. This will help you with accuracy. Your intuition will help you better when you're doing distortions, unless you're just a real engineer nut, you know, and you want to do curved picture planes and double picture planes and stuff like that. If you take the time to understand this, I could have done more. I could have done so that this thing had a thing sticking out there, but you've got the same thing going on. You're going to have to take that corner to the viewer and that corner and that corner, and you're going to have to find whether this is higher or lower, right? If in the side view of that, it might be shaped like this, or it might be shaped like this. And do you see how you'd have to project that line, the height of that line, forward, and then run it back in perspective and find where it would be? The books will show you how to do that. Because obviously doing a house is a lot more complicated than doing this. But if you'll do this a few times to get it, it will develop your structural imagination. And one of the first things he had you do in there to develop your visual imagination was to take one view of something and to imagine all the different ways you could do it. I found it really tough. But I don't find it tough now. And the reason why is I understand this. I understand the top view is not the side view. The side view is not the front view. And if you can get those categories out of the mush of your mind, if you can get them stretched, put into their own category, and then see how they connect in a plan projection, then you can look at the top of a circle. You can look at a circle and say, it could be the top of a sphere. It could be the top of a cylinder. Or it could be just a flat circle. Right? It could be any of those things. It could be a dome. You got to see the side view, and then you see the side view. Oh, okay, that tells me what it is. Right? If I had put a circle in here, that could have been this, right? But it also could have been this. In that case, the circle would have been a dotted line to show us that it's underneath there. Or it could have been this. It could have been one of many things. That's, to visualize those things is called structural imagination. It means that you can image. The root word of imagination is image. It means thinking in pictures. You can image things that don't exist in space yet. You can close your eyes and let the motion picture screen of your mind talk to you. Now, we are all learning the principles behind what that computer is doing. Everybody who works with type now in the commercial world does it in computer programs, Quark or Illustrator or Type Chameleon or whatever else you've got, because that's the most efficient way to work with type. But you know, Graham is really big on that you ought to do it the old way first. And people bitch about it because they've got a hand letter. I did hand lettering in there years ago. My love I thought might be type, and I dropped that love because it was competing with other loves. But doing type by hand is good. I wouldn't insist on it any more than I would insist that you retouch photographs by spraying acrylic paint and working color pencils on black and white prints, which I've been doing for 10 years. But there's an advantage for me having done it, that when I get in front of the computer, within 6 hours, I'm roaring at the computer because I've been through all of this stuff that got me prepared for it. Whereas if you're starting with the computer, all you're starting with is the computer. You've still got a few years of studying light on form and what makes a photograph look like a photograph and not like a drawing or a painting. So there is an advantage to knowing the old stuff, but it can be overdone. You know, you can start on the computer and be the world's greatest photo retoucher or type manager without having known the old way at all. But it can help to know that. Of course, for us, this has nothing to do with designing on the computer. This has to do with, if you're going to have to do an architectural illustration or whatever, and you got a computer program that does that, why do this? But there's an advantage in doing this in that when you're doing that on a computer program, you understand what's going on and you can override it, be more creative with it. You can master it instead of being forced into thinking, well, this is the way the computer does it. I have no idea what it's doing. If you know what it's doing, you can play with it more.